I am Mr. Ish and I'm welcoming you to this video. I hope everyone's doing well. For all of you students in math, especially at the high school level, you've learned, particularly looking at this one example, if you do 1 divided by 0, you know that's undefined. You do not divide a number by 0, and normally you can write your answer as undefined, and some students symbolize it as this. Whether it's appropriate or not, but many students do it and they get away with it and it's fine. And here I'm particularly saying it's 1 divided by 0, but it could have been any constant number divided by 0, as in 7 divided by 0, 11 divided by 0. It could even be a negative number, but then you'd be flipping things around in terms of a reflection on a graph. But generally, let's look at the positive numbers. If you're looking at this type of situation, when you have a function 1 over x, it looks something like this, and you know it. You have the horizontal asymptote, you have the vertical asymptote. But as the numerator gets larger, let's say 11 divided by x, then the function curve gets pushed further away from the asymptote because you have a larger number on the numerator. Your graph looks something like this. The larger the number, the further you get pushed away from the origin, but eventually and further away you still cling along the asymptotes. The smaller the numbers in the numerator, like you can say 1 over 3 over x, or you can say 1 over 2 over x. Of course, the 3 and the 2 can come down and it can become 1 over 3x, 1 over 2x. But anyhow, the smaller the numerator, then the closer you are to the origin, and your function looks something like this, graph-wise. But it's still going along the asymptotes. But the smaller the number, the closer to the origin. At 1, you're a little further away. The larger the number, you're much further away. Why am I showing you all of this? Because you're seeing over here that asymptotes are involved, particularly a vertical asymptote. If x were equal to 0, now your function has to graze along a vertical asymptote from both the right and the left sides. What are we going to do in this video? We're going to focus particularly on this, and we're not going to be thinking about undefined or this anymore. We're going to start mathematically giving it a proper answer. Anytime you see something like 1 over 0, especially when you are going to go into calculus, you might want to start thinking your answer could be positive or minus infinity, an assumption that will help you quite a bit when you are doing integrals. So let's spend the remainder of this video and I will tell you why you rethink this entire 1 over 0 and you don't call it undefined anymore. Every time you see 1 over 0, you will rethink your thought process and you'll give it a value, a positive or minus infinity, because everything will come by means of this limit as x approaches 0, 1 over x is equal to what? Evaluating a limit at 0, and I've told you this right here is a vertical asymptote. If you are looking at those values of x which are approaching 0 from the right, you know 1 over x, it looks something like this and it looks something like this. When you're approaching the values of x approaching 0 from the right, your function is going up towards what? It's going up along a vertical asymptote towards positive infinity. If you are evaluating this same limit as x approaches 0 from the left, you're approaching the values of x towards the 0 from the left, you're looking at the curve and it's approaching now in the direction of minus infinity. Hence, I've put positive or minus infinity because based on the situation, you're not going to call it undefined or you're not going to give it this representation anymore. You'll pick either positive or minus infinity, and that right there is the reason by means of this limit you have to rethink your procedure. And of course this 1 could have been any other number, but at any time you're looking at a constant divided by x, maybe you don't want to think about undefined anymore, but you want to think about this because these are now values or representations you can do something with in calculus. If you were to say 1 over x is equal to undefined, you've put an end to everything and you're not going to do anything with it. But if you're going to say 1 over 0 is equal to something like this, now you can do something with this, particularly when you do integrals. So keep that in mind. This is what you're going to rethink in terms of your thought process. 1 over 0 or a constant divided by 0 can, by means of graph and limit representation, be one of these two values. That right there is the end of this video. Have a good day.